Okay, I didn't finish the example today in class, so I'm going to talk about it here. So it's question number 2 from page 533. Check your understanding. We were kind of making some notes on the board. So I did this. I had students in the office, so I couldn't record this, but I need to use my time when I can. This says converting from graph to equation. Continued, because we had done A and we had done D, as in the what does A and like Y equals A sine B of X minus C plus D. We had done the A, we had done the D. We were talking about B. Now basically, this period, which I in my rush did a little incorrectly, I think, in class, it goes from negative pi to 7 pi, sorry, negative pi over 12 to negative 7, say that again, negative pi over 12 to 7 pi over 12. So this is negative pi over 12, one complete cycle, not over here, one complete cycle. This is 7 pi over 12. How, excuse me. How do I know this? This is 5 pi over 6. So these don't go up by pi over 6, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They go over 12s. So 1, 2, 3, 4, 5, 6 pi over 12, that's a half. 7, 8, 9, 10 pi over 12 is 5 pi over 6. So anyways, it comes to here. So just count your way over. 1, 2, 3, 4, 5, 6, 7. 7 pi over 12. It starts one back. Which means whoosh, the period, that range between these two, is a period of 8 pi over 12. Simplify, that's 2 pi over 3. Now, an original period of 2 pi means, generally, if we want to find out the period of something, we say 2 pi divided by b if we have the equation. Here, we have the period. So we're solving for b. So it's 2 pi over b equals 2 pi over 3. Because 2 pi over 3, move this. 2 pi over 3 is the period. We need b for the equation. Well, everything's equal here, so b equals 3. B equals 3. Last but not least, C. The phase shift. How do I do this? The phase shift. It can be interesting with these functions because they just repeat over and over. So really, the phase shift could be right. It could be left. In this case, if this is sine, we don't even know if this is sine or cosine. If this is sine, it's a sinusoidal. That means sine or cos. If it's sine, it has moved over 4 pi over 12 because this is where it's supposed to start. Okay, like it starts and then goes up like this. That's where it's supposed to start. That's 4 over 1, 2, 3. Oh, 4. Sorry, I can't count. 1, 2. What? That's 3 pi over 12. Okay, so that's what that is. Screwed that one up, hey? We'll just double check. 1, 2, 3, 4, 5, 6. Poopy. 3 pi. Okay, well, we'll make the changes here. That's why you don't rush. 3 pi over 12 or pi over 4. 3 pi over 12 or pi over 4. I'm just going to keep it simple. Just leave it like that. It could be a negative if it was if it's actually moved over quite a bit. But let's just keep it simple for now because I realize I screwed that part up. If it's cosine, it was moved over negative pi over 12. Let's just ignore this. It was moved over because it's moved over just the 1. Because if it's cosine, then it starts here. That needs to come here. So it's just moved over 1 block, negative pi over 12. That was from the example today. Hopefully that makes sense. Glad I caught the mistake again.